So start up for week number 13. Number 1 says solve each proportion. In order to solve proportions, your cross products must be equal. So that means I must take 9 and multiply it times 3, and it will equal 6 times k. So we have 27 is equal to 6k. Now, when we solve proportions, you do not ever round a decimal. If you round the decimal, it will be counted wrong. And the reason why is when you round a decimal and you plug it back in, you do not get equivalent ratios. So you leave it in a reduced fractional form. We want to divide, simply solving the equation, dividing by 6, both places. If it reduces, reduce it. If it doesn't, leave it as an improper fraction. Now, if the decimal terminates, that means stops, cuts off. Like for this particular one, this would be 4.5. That is acceptable. But if it does not, then you cannot round the decimal. My rule of thumb is always just leave it as a fraction and reduce the fraction whenever possible. So we can look at this and what? 3 goes into 27 9 times. 3 goes into 6 2 times. So k is 9 halves. Leave it like that. Number 2, solve each proportion or solve the proportion. Still the same process. Your cross products must be equal. 9 times the quantity p plus 5 would equal p times 10, or 10p. Solve the equation. It's a multi-step equation where we have to distribute the 9. So we have 9p plus 45 is equal to 10p. I'm going to subtract 9p. So 45 is equal to p. And that is how we solve that. Cross products have to be equal. Number 3. Number 4. No, we can't see them both together. Number 3, it says state if the triangles in each pair are similar. If so, state how you know they are similar. Now, there's a couple of ways that we can determine if triangles are similar. First of all, angle-angle similarity. We can have angle-side-angle similarity. We can have side-angle-side similarity. We have side-side-side similarity. Looking at this particular one, we have common angles that are vertical. So that means it throws this one right here out. It throws this one out. So there's only 2 possible options right now. It's either angle-angle or side-angle-side. Now, in order for it to be angle-angle, I have to know another angle is congruent to another corresponding angle. There's not any. So our only option at this point is side-angle-side similarity. In order for it to be side-angle-side similarity, the corresponding sides must be proportional. And the way that you check for proportionality, because we don't know, by looking at the picture or the diagram, we don't know if H corresponds to V or if H corresponds to U. But I do know that the shorter side between HT and GT will correspond to the shorter side of VT and UT. So if I'm looking at it that way, the shorter side 16 corresponds to 23. And so 26 would correspond to 38. The only way that these 2 triangles would be similar is if this proportion or is a true proportion. So we check to see if it is. Now, how do we check for proportionality? 26 times 23 must be equal to 16 times 38. So all we have to do is simply take our calculator and multiply here, because we have the common angle, vertical angles at, what is that, vertex T. So we're going to say 26 times 23. I get a number of 598. And then we want to say 16 times 38. I get a number of 608. These are not proportional. So state if the triangles in each pair are similar. If so, state how you know. They're not similar. If they were similar, instead of saying not similar, I would state side, 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 angle, angle, whatever similarity it would be. I would just simply write those initials. So in order to check for similarity, I have to have corresponding congruent angles, or I have to have corresponding proportional sides. Number 4. State if the triangles in each pair are similar. If so, complete the similarity statement. So now we want to determine if they're similar, and if they are, what triangle is similar to what. It doesn't say by how, but just which triangle is similar to what. And you can't see this because of the screen, but down at the very bottom, it is saying triangle DCB is similar to what? First of all, we have to determine if the triangles are similar. Looking at it, first of all, from the get-go, I have vertical angles. So there's one angle. These arrows here and here represent that I have parallel lines. Parallel lines cut by a transversal means that I have alternate interior angles congruent. That's enough for me to stop right there. Angle C is congruent to angle T. And at vertex D, I have vertical angles. So I have two congruent angles. I don't have to state this, but these two triangles are similar by angle-angle similarity. Now, what are the corresponding parts? Well, D corresponds to D. Let me change color. Sorry, that yellow is hard to see. Triangle or vertex D corresponds to D. Looking at angle C here, what corresponds to angle C? Angle T. And the only one left is U. So triangle DCB is similar to triangle DTU. State if the triangles in each pair are similar. Yes, they are. If so, complete the statement. To me, on this problem, where it says state if they're similar, I don't think that we need to say yes if I know this right here. Now, if they're not similar, yeah, you need to say no. If they're not similar, you cannot complete a triangle similarity statement. There's no possible way because they're not similar. But yet some of you still try to do that. So if it's no, you're going to leave that blank blank. Number 5, solve for x. The triangles in each pair are similar. So if I know the triangles are similar, then I know I have congruent corresponding angles, or I have proportional corresponding sides. Now, looking at these drawings, I can see that angle N is congruent to angle F. I can see that angle M is congruent to angle E down here. So that doesn't help me out because I'm not dealing with angles, I'm dealing with sides. But proportional sides are opposite, not proportional, corresponding sides are opposite congruent angles. So that means that 4x plus 6 corresponds to 65. So that means in my proportion, they are going to be in the same location. Either both on bottom or both on top. And 14 corresponds to 35. I simply now solve the proportion. Cross products are equal. 14 will equal, or not 14 equals, 14 times 65 will equal 4x plus 6 times 35. We solve the equation. 14 times 65 equals 910. I'm going to distribute 35 to 4x and 6. So 4x times 35 gives us 140x. And 35 times 6 gives us 210. solve the equation, I need to subtract 210 from both sides. So 910 minus 210 is 700. And that equals 140. X. Divide by 140, both sides. Remember, if it terminates, we can leave it as a decimal. If it does not terminate, we want to leave it as an improper fraction. But in this case, x equals the whole number 5. So we're good. Number 6 says solve for x. Very similar to the last question. Here we're given parallel sides. Now, there's a little bit more to this one for the fact that they don't give us this segment measure here. They give us the whole side. Remember, when you're dealing with similarity, you have to match up proportional parts or corresponding parts. 6 corresponds to 4. X corresponds to this part right here, which if we want, we can call Y. Now, to some of y'all, that is messed up. That's confusing. Can I figure out what Y is? Yes. If I know the whole side is 10 units and only part of that is 4, what's left over? Y equals 10 minus 4, which is 6. So I solve for x. 4x equals 6 times 6. 4x equals 36, or x equals 9. So sometimes you may have to do a couple of steps before you can even set up your proportion because of the parts that they give you. That's your startup for week number 13.